This is section 4.3, part 5. If we look at this system of equations, we again do not have our x and y on the same side. So I'm going to transform this second equation. I'm going to start off by moving the 2y over to the left. So add 2y to both sides. 5x plus 2y plus 3 is equal to 0. Now move the 3 over, subtract 3 from both sides, and we have 5x plus 2y is equal to negative 3. So the system I need to solve, I'm going to recopy the first one. And then the second one is 5x plus 2y is equal to negative 3. Okay, so we need to pick a variable to get rid of. Remember, it does not matter which one, you just make a choice. None of these numbers look particularly nice, but I do have an advantage with x because one of them is positive and one of them is negative. So I'm just going to look at the 4 and the 5. If I thought of these as denominators, my common denominator would be 20. So I'm going to turn the 4 into a 20 by multiplying by a 5. I'm going to turn the 5 into a 20 by multiplying by a 4. Now double check your signs, make sure it's going to be right for you. I'm going to have a negative 20 here and a positive 20 here, so that's going to work. So make sure you multiply all the way through, and you get negative 20x plus 15y is equal to 10. And then multiply here, positive 20x plus 8y is equal to negative 12. Add these together, the x's go away. I get 23y is equal to negative 2. This looks ugly, but sometimes answers are ugly. I need to divide both sides by 23. And your y value is negative 2 over 23. I told you at the beginning of class, the first day, you're not going to be avoiding fractions, and here they are. We've got to deal with this. I need to take this value and plug it into one of these two and solve for x. Remember that you have fraction buttons on your calculators. This is mine. My fraction button is right here. I forgot to pick up one of our classroom calculators before I left, so the best I have is a printout. And it's not a very good printout, but the fraction button is right here. And they work basically the same way. So what I'm going to do is I'm going to take this value and I'm going to plug it into one of these two. Let's do this one. Negative 4x plus 3 times negative 2 over 23 equals 2. This is 3 over 1. You can multiply straight across. Negative 4x minus 6 over 23. 3 times negative 2 gives me negative 6. 1 times 23 is 23. Is equal to 2. Now I want the x alone, so I need to move this over here. So I'm going to add 6 over 23 to both sides. Negative 4x is equal to. Now if you're doing this by hand, you would write this as 2 over 1, get a common denominator, and add them together. If you use your calculator, you get 52 over 23. Now we want x by itself, so I need to divide both sides by negative 4, and I'm going to write this as divided by negative 4 over here. So writing out a couple of extra steps, you can do this on your calculator directly if you want to. But this is the same thing as 52 over 23. That's negative 4 over 1. Keep it, change it, flip it. So this is times negative 1/4. The 4 and the 52 will reduce. If I don't make the paper run away from me, that would be a 1, and that's a 13. So my x value is 13 times negative 1, negative 13, over 23 times 1, 23. So your answer is negative 13 over 23, negative 2 over 23. And I think here you'll see the advantage of using the elimination method over the graphing method, because you could graph those two lines and you could graph them perfectly, but still as humans, I would not be able to read this off of a graph, okay? Another thing to remember is that in my math lab, sometimes it does give you ugly numbers. If you want to deliberately get something wrong 3 times, hit similar question and hope for better numbers, absolutely do that.